Okay, so good evening, guys. So today we will see that how to use the tool runner to avoid the rebuilding the code and again and again. So in the last class, you have seen that we have ran many programs, and we have seen that how to use the job queue name, how to use the maximum split size, how to set the number of reduced tasks, and a lot of other stuff. And each and every time you have observed that we have to go back to our code, we have to change the code, and since you have changed the code, you have to build your code, and then you have to move your jar to cluster and then again deploy. So this was a very pain this so that was a very painful job. So today we'll see that how instead of changing the code, how we can provide the parameters at run. How we can provide the parameters at runtime, and that's we'll see. So for that, we have to change the driver code. So for this to happen, we need to change the driver code. The driver code is nothing but the class which has the main method. So this is the driver code which has a main method, and we have to change the driver code the way it is written. It's not a very drastic change, it's a very simple change. So you have to uh, extend your driver code from the configured class, extends configured, and implements the tool interface. So tool would be org Apache Hadoop tool util. So this is the class you have to, and then you have to implement this tool interface, extends configured. So configured class is required so that we can use the get configured method. So the other day in the last class, I was telling you that you have to explicitly set the address of the name node and the address of the job tracker, sorry, the resource one, everything. But that's every time you have to see actually this might change also. If you are going to run your this code into some other cluster, then you have to appropriately provide the address of the name node and the address of the resource manager. Instead of that, you take the configurations from the machine itself. So the configured class gives a method known as get configured. I believe that's the method name, get configured. And this method will take the configurations from the machine. So since we will be running, since we will be running our code from one of the client machine is where we have installed the client libraries. So one of the client machine, so it will automatically find out the configurations. So you don't have to explicitly set like this. That is the intent of using the configured uh, class, extending our class from the configured class. Implements the tool interface, it will give us the run method. And when you put your mouse over here, it is asking us to add unimplemented methods. It's basically asking us to add the run method. Yep, so this is the run method. You don't have to do anything. I'm replacing arcs of 0 by, I'm just replacing 0 by s. I'm replacing, yeah, so instead of arcs s, this one. And I will take up the entire code which was there right now here. I'll take up this entire code which was in the main method. I will paste it here in my run method because this is the method which gets called. So this is the main method which gets called. So that's why I have taken the main everything from my main method and kept it here. And also I will remove everything, and I will say get conf. That's the method. So see this, that's the method I wanted to use. So I was actually wrong, it was not a get configured, it's a get conf method. Okay, so the job.instance get conf and rest of things, so we are not going to change anything. And in the main method, which is your main method, which is your entry point to your job, so it will, you just need to say toolrunner dot run new, and just give your class name the word count driver, because that guy is implementing the tool interface. And arcs, you put your mouse here and it's asking to throw the declaration, so I will throw the declaration, and that's it. You don't have to change anything. You don't have to change anything. And now here everything is done. So this is, so using this, the way we have written driver code, if we write this driver code, then I will show you very shortly that we don't have to change the code at any given point of time anymore. Now we can provide the configurations we can provide the config, or we can provide, you can change the configuration at runtime when we are submitting the job. So you will see that very shortly. And before that, let me start the cluster. Oh, can you hear me? Can everyone hear me?
Yes, yes, yes.
Kushbu, can you hear me? Okay, I will let it start. Take some time to start. Let us go back. So, and using the tool runner. So now you want it. So by using the tool runner, by using this interface, by use the way we have written this tool, the way we have changed our driver code a little bit. So using this, now we will be able to provide the configurations. We'll be able to provide or change the configurations at runtime. And please understand, we can change only the default only the default values, and the default values are those values which are not set in the driver code. Values which are not set in the driver code explicitly, you can change them. What I mean by this is that if you have set the number of reducer tasks to 0, so you cannot change this number of the number of reducer tasks for this job is now set to 0. You cannot change that. You cannot change it. Now, if let's say if you want that flexible, if you want this flexibility, like I want to change the reducer tasks now and then, so you don't have to set it here. So remove this. Now, if you have removed that, that means to say that we will be able to change the reduced tasks at runtime. Yeah. Similarly, you can do a lot of things, but let me just go one by one. Now I also don't want to set the job name. I wanted to provide this job name at runtime, different job names. But if you have set it like this in your driver code, then you will not be able to change it. So that's why I'm changing it here. Okay. So a couple of things I have changed. So I in fact I can change the entire thing, which I'll show in the next exercise. But for the time being, just we have started. So let me give you the hang of this now. Okay. Am I audible to everyone?
Yes, I can hear you. But the others are not active.
Okay. So I was explaining you the usage of the tool runner, which we have just did it. So let me just take you through the code. So the motivation of using the tool runner is that it allows to specify the configuration options from the command line. So you can see. So we will see that very shortly, that how we will specify the configuration. You can specify the distributed cache properties. Distributed cache is a very important concept. For the time being, let us skip this distributed cache. We will talk about this in detail later. And it can be used for tuning MapReduce jobs. What I mean by this, that it can be used, tool runner is a flexibility actually. So it gives us the flexibility to provide the configurations at runtime. So which means that, for example, I would like to see that how my MapReduce job performs when it has 10 reducer tasks. How my MapReduce job performs, or how much time does it takes to complete when I have 6 reducer tasks, when I have 2 reducer tasks, when I have 5 reducer tasks. So you want to have this trend, that and you wanted to find that optimal number of reducer tasks for your job. In that case, you don't want to change your code every time, right? You don't want to take that pain of changing the code, rebuilding the code, moving to the cluster, and then deploying it again. Instead of that, you wanted to have the same jar created once, and then you provide the parameters, right? So that's the usage of tool runner. And for that to implement, you actually uses the to implement, your class should implement the tool interface. And regarding the configured class, I have explained you the configured class provides you a getConf method, which will read the configurations from the machine. And of course, you will be running your job from a machine where the client libraries are installed. Okay, and it will look like this. You will have a run method, which is actual method where your actual job code will go, and the main method just need to call toolrunner.run new your driver class name and args. And then how will you do that is the using the minus d. Minus d is an way to provide the properties via the command line. And for that, you need to understand that how do you provide the properties is using this. Okay, I don't have. Okay, let me. So, for example, you want to change the number of reduce tasks. So right now you have ran your driver, submitted a job like this Hadoop, your jar. Then you have to given your jar name, uh, fully qualified driver class name. Just give me a moment. I will start up the cluster, start up my HDP cluster. jar name, and then you used to give fully qualified your driver class name, followed by your input path, and then output directory where you would like to store your input out results of a MapReduce job. Now, if you want to give any other property, if you want to give provide some properties, then it has to given like this. Everything remains the same. So this is a fully qualified driver class name. This is the input. It always has to be in between these. You have to give minus d. You give some property name equal to some property value of the property. This is how you need to give. Okay, so everything has to be given between this. So minus, it started with minus d, the name of the property and the value of the property. There are a lot of properties which can be given, and some of the properties are like mapred.reduce.tasks. It is this property is used to specify the number of reduced tasks. Property to specify the number of, by this time a lot of properties which we have dealt with when we are doing the installation, but these are the map related properties, so you might not encounter this, but let me just, that's why here it is. Mapred.reduce.tasks. This property specifies the number of reduced tasks. um, fs.default fs. This property specifies the address of the name node. Mapred.job.name. This specifies the address. This property to specify the name of the job. MapReduce.map.class. This property is used to specify the class map the specify the mapper class. MapReduce.reduce.class. So this property specifies the reducer class. Similarly, you have lot of properties to specify each, and I think you have properties for each and everything. I think if you map-reduce.map.output.key.class. Remember, this property is the what is property to specify the output key class of your mapper, and this is how, and how do you specify that? Here you specify, like in your, if you want to hard code this, then you say map output key value class. So map output key class. So similarly, there is a property already defined here, mapreduce.map.output key class. So I'm not sure if this is the exact property, but there is a property, so we can figure it out. We can, let's see. And I can, yeah, mapreduce.map.output key.class. So you actually take up the mapred-default.xml, and then you have the list of all the properties. You can actually take out every properties from here, right? So all the map-related properties can be taken up from here, and all these properties, or in fact any properties, can be changed via runtime. Hmm. Oh, I'm not sure what is the mapred.reduce.tasks. I'm sure that this is a property, but I don't know. This is release 1.4. and this is release 2.7.2. Okay, let us take the latest one itself. So what is that? Mapreduce. Reduce. The mapreduce dot task tracker dot. Oh, okay. Let me check. Mapred dot reduce. There is no thing. Mapreduce dot reduce dot. Okay. Mapreduce log level CPU cores number of reduced tasks default number of reduced tasks per job. So mapreduce.job.reduces. This is a property, I believe. The default number of reduced tasks per job. Typically, the cluster reduce capacity. So if a node fails, it can be still be executing single wave. Ignore when the mapreduce.job tracker address is local. So this is the property. So there are a couple of things which we have to see here. This is the latest version of 2.7.2. And the one which I have shown you, mapred.reduce.tasks, that was 1.0.4. It will see the descriptions remain the same, but we are going to use a newer one, mapreduce.job.reduces. Okay, and let us see that here. Our cluster should be up and running by this time. Yeah. Now, what we're gonna do here is we will build our code and we'll deploy onto a cluster. The project name which I have used is the word count. Maven clean install. scp-i HadoopTraining.pem ec2-user at. Okay, I need to transfer this target word count shader.jar to ec2-user at. I need to get the host name. Okay, :/home/ec2 word final.jar. So let me log into that machine. So what final.jar, this is the jar, and we know now Hadoop jar name, that's your word final.jar. Then fully qualified driver class name. So select your class, right click, copy qualified name. Okay, and then input data. I forgot. Okay, let us first, since this cluster is curverized, I need to get a new token. You don't have to do that if your cluster is not curverized. Okay, I have 29th May and tomorrow it's 20, yeah. And I got the ticket, Kerberos ticket, Hadoop FS minus LS. Let us see where is our data set. I think input underscore data was the one, yeah. I was been using last class, right? Okay.
Kerberos is only for security purposes, right?
What is that?
Kerberos is only for security purposes.
Yeah, yeah. For authentication, authorization, security. Correct. So Hadoop jar, your mm, jar name, fully qualified class name. Select, right click, copy qualified name. Okay, and then you have the input data. But before that, I wanted to see. Okay, first and the foremost, since properties are changed, I would like to find out that what is the job name corresponding. Okay, command o job dot name. There is no job name. Map reduce dot job dot. I'll go back here. I'll search for mapred dot job dot name. Mapreduce dot job dot name. Ah, okay. The new property is the mapreduce dot job dot name. I better uh, bookmark it. You can also take up this. You can keep a track of this so that if you are using older property, should not use it. No more deprecated properties, so you can keep a track of this. Bookmark it. So I will use this minus d mapreduce dot job dot name. Now I'm submitting. I give the property, and that's my property, and the value could be let's say word count default job, something like this. Input data imp underscore data, and output result opp output 001. I think I have to give the queue name also. Okay, so I have to give the queue name, so I can always give like this minus d mapreduce dot queue name minus d. So you can see that I'm giving two properties at the same time. Minus d mapreduce dot job dot queue dot name. I can give it as a QA. I remember the queue right now. And where is my input data? Oh, I'm very sorry. I have to give only between the driver class name and input data, not after that. So I have to give. So this is my input data. So I'm going to give before my input data minus d, my property name, and the value of the property is QA, and then I enter. I'll go back to my UI to figure it out whether it has taken place the job name or not. I'm just starting with the smallest. I mean to say, you have seen that I can provide more than one property also, but I'm starting with the smallest. I mean, this minimal. That is what is my job name. Am I able to change my job name or not? Yes, I'm able to change my job name. You can see that whatever we have given in the command line, that has actually taken. I think this is the where we have given default job, right? Just give me 1 minute. Okay. Now you see that without changing number of reduced tasks, without changing the code, I'm going to provide a different reduced task. So let us figure it out how many reduced tasks it ran actually. Okay, so this was the job. I can click on the job. Okay, it will not take me to the history URL. If I click on the history URL, ideally it will not take me. Yeah. The other way to go to the history URL is to go to MapReduce, job history UI. And then this, if you see this job, if you see that this is the job which I have just started, the first one. You can see the job name here. You can, if you observe here, the number of registered tasks is 1. Now please note that I'm not gonna change the code, but instead of that I'm gonna provide my number of registered tasks via the command line. So I'll give a different job name here. What count 0 reduce tasks. So that's my job name, and basically the job name says that I wanted to have a 0 reduce task for this job. So minus d, and let me take up that particular mapred.reduce.task. The deprecated, I'm going to take the new one, reduce.task is mapreduce.job.reduces. This is the new property, mapreduce.job.reduces equal to 0, and let us run it. Okay, the output directory is the same which I have given as the previous directory, the previous jobs output directory is the same. So I have to give a new one, or either I have to delete the previous one. So I'm going to give the new one. Okay, I'll go back. refresh my job history UI, you can see that the job name has changed, and also please see this number of registered tasks is 0. So you can do everything, whatever you wanted to do. In the last class, if you want to do whatever you want to do without changing the code, you can make your you can provide different values. But please note that only the default values can be changed. Now, what I mean by that is if I explicitly set the number of registered tasks in this, let's say, job.set num reduce task, and if I explicitly set the task to as 10, num reduce the task to as 10, then I will not be able to change via the command line. Whatever you do, it will not you will not be able to change it, because even though if I give 0, it will still run the 10 reducer task if I have hard code in my reduce task, because the priority is that it will take it the driver code. It will take it from the driver code, the final values. But if it is not specified in the driver code, then it will actually take it from the command line, whatever you have provided. Okay. So that's how you have to use the tool. You can use the tool runner, and you can make your life easy by providing the properties by the command line. Now we have done.
I have a question actually. Um, yes, in the driver class, we have specified that the number of reduced task will be 10, and if we don't provide the number of reducer task with hardcore via the command line prompt, then the number of reducer task will be 10, right?
Even if you provide it in the command line, assuming that your driver code
Hmm.
is always 10, right? Let me just show you. So assumption is I'm hard coding to 10 reduced task. I will build my code because since I've changed the code, right? So I have to build my code.
Hmm.
Let me delete the rm minus f word final. That jar I'm deleting it. Then I'm building it here. I'm moving this jar to my cluster. Now I'm going to run the reducer tasks as 0. But so here you have provided number of reducer tasks as 0. It will not take into effect because you have explicitly set it over here. Go to yarn, open up the active resource manager. This is the job which is running. I cannot ever go to this application master because I have to provide the actual IP. This is the IP. I have to provide this actual IP here. 10 reducer tasks are running, so it's going to take some time.
Uh, so one question here. If we have any sort of job, can we make reducer to 0, or for certain jobs, certain sort of query, we should be having reducer?
You can make it by, as I've just shown you, that by providing at the command line, you can make certain
Yes.
type of it's your flexibility. Once Once you have not set the number of reducer tasks, that means the by default it is set to 1. If you even if you don't change it, even if you don't give it in the command line, so and you have not set in the driver code also, which means that it will run one reduced task. Now since
Okay.
you are not providing the driver code, now it's up to you that for a given job how many reducer tasks you want to choose, and you can give it via command line, and you don't have to change the code for that. But once you have hard coded, just now I have shown you that in this driver code I have hard coded the number of reducer tasks as 10. Okay, and you see it here. It is 10 reset tasks. But then I in the command line, when I am submitting a MapReduce job, I have given the number of reset tasks as 0, but it has not changed. Which means that whatever if you want to change something via command line, you don't have to explicitly set in the driver code.
Okay.
Okay. Uh, Now, what all things can be changed? So let me just cover the last bit of it also. That I will, what I'm gonna do is input format, output format. Okay. I don't remember all the properties, but what I'm gonna do now is to create an XML file. Mm, I just need the XML tags. So mapred hyphen default. This thing I wanted. Okay, let me now what I'm going to do now is to provide all the properties via the command line. Now every if you have seen this, when I was submitting the MapReduce job, you might have observed that you can give as many properties as you want, right? You have seen as many properties as you want, you can give it. I think the last one I have given three properties: my job name, queue name, and the number of reducer, MapReduce job dot reducer. You can give n number of properties here, but then again it's becomes very cumbersome. So what we're going to do now is to give the properties via the command line. So let's say sorry, I wanted to give all this property. I wanted to give specify all these properties in an XML file, and I will give this XML file as an input to my MapReduce job. So let's say my conf.xml. Okay, and then it should start with the configuration. Okay, let me type it configuration and ends with the configuration. This is how the XML file should look like, where all the properties you're gonna specify now. A property and starts with the property and it should end with the property. and a property has a name and a value. Name and a value, and let's say the value name, the first and the foremost. I'm gonna provide each. I can provide everything actually. So in fact, I mean to say we can specify the address of the name node. We can specify the address of the job tracker. Sorry, resource manager. We can specify the number of reducer tasks. We can specify the mapper class, reducer class, everything. So we'll start with the let me just say fs.default fs, right? So the value of this property was, I don't remember, but I can figure it out. I can go to HDFS, I can go to configs, and then I can search for fs.default fs.default.
This properties are already defined, right?
Yeah, so but this is for my job. For my job, I might want to, you will see that in the next class when I will show you the debugging, then the property of this fs.default fs will change. So for a particular job, you might want to run on the cluster. For a particular job, you might want to run on the local file system. So with the XML file, just change the properties and your job is done. This is per job configuration. What you have observed when I am providing the properties over the command line, what you have observed that I can provide different properties for different jobs. So that's what I'm
Yes.
creating a set of properties for my job.
Okay.
Okay, and I'll go to resource manager address. I wanted to find what is my yarn dot resource manager yarn dot resource manager. This is a property name. So one time we had to take a pain that getting these properties and everything, but the next time onwards it becomes very handy because I'll be using the same XML file everywhere. Okay, and then you wanted to specify the address of the what do you say, the number of reduces. I can always specify. Now you'll see that now how easy our code will become. That now I wanted to specify the mapper class, so I can always specify my mapper class as well. But the property I just need to check here, mapred mapred.map.class. mapreduce.job.map.class. This is a property name, mapreduce.job.map.class. I think the m has gone, and the value would be the my mapper class which I have used. So that's a word count mapper. But what I have to do, I have to take up the fully qualified name. So I select my class, right click on it, and say copy qualified name and paste it over here. Similarly, what I'm going to do now, I'm going to add my uh, reducer class, and for that I have to take up the property. It is mapreduce.job.reduce.class. It's just a change of the name, job.reduce.class, and it would be word count reducer, word count reducer, right? Let me just confirm it here. So if you see, what I have done is I will anyways remove my set job.set mapper class. Since I have provided in the my in the XML file, I can remove this Okay, I have reducer class I have given. I can remove this. Set reduce task. I know how to give it. I will let us give it here first. Okay, so map reduce dot um, the property name was mapreduce dot job dot reduces. That's the property name. And let us give the number of reset tasks as 0 as of now. I don't want any reset task to run. Now what else is there? Okay, map output key value class, map output key class, map output value class, reducer output key class, reducer output value class. Okay, let us give that. Let us take up the corresponding new property here. Map reduce dot mapped out this one. Map reduce dot map dot output dot key dot class. Okay. Okay, that's our text key class is a text, right? So if you open up, if you're not confirmed, so open up your word count mapper. This is the output key. Input key, input key, input value, output value. Output key is text, output value is int writable. Okay, text, I have to take the entire thing and I paste it here, the fully qualified class name. Now, similarly, I can provide my output value class mapreduce.map. Let me check the property. Map output value dot class. Instance of key, it will be value, and the value of this property would be int writable. So I'll go to my Eclipse and I will just take up this. Okay, and paste it over there. Now I can go to my Eclipse. So I have go to driver code. I have now I have given the map output value also, map output key class also. Slowly you are seeing that your driver code will become very generic. You are removing one by one each and every property and providing the XML file, and that XML file will become like a template for you. You can use that XML file for different jobs and just change the values. Now output key class and output value class, that's a reducer output key and the reducer output value class. Let me take up the correct property, I mean the newer property which is there. Mapreduce dot output mapper output, so it is a mapreduce dot job dot output key class. What was the other one? Mapreduce dot map dot output key class. Okay, and that was mapreduce.job.output key class, mapreduce.job.output.key.class, and output.value.class. Okay, and this is your reducer output key class, which you have specified there, and it is, I believe, output key class is also reducer. This is input key, input value, output is text, output key is text, output value is long writable. So it is text, and this would be output value class. Change it to key to value, and the value is of type long writable. Okay, and we have given the output key class, output value class. This is also not required anymore. Now input format. Okay, there's also, if you have seen that, we have property for each and everything. Now let us, I'll just check up this mapred dot input. I forgot the property name, but input format. Okay, we have other method to do that. Not a problem. We have other way to figure it out, that what are the various input for. What we can do is we can actually go to user. Let me just check once. Do we have the logs folder? Cd user HDP. I'm very sorry, log folders will not be here. Where log Hadoop MapReduce Mapred. Not here. Okay, let us forget it. So we will properly specify the input format. Uh, MapReduce. MapReduce job.inputFormat.class. I think that is the property which we are looking out for, but we'll check it. Yeah, MapReduce.job.inputFormat class. This is the property which I was looking out for, and again I will go ahead and provide it here. Okay, vi myconf.xml. Okay, so this is the class name, sorry, this is the property name, and the what happened, and the input format class is, by default the class is text input format. Let us give the fully qualified class name. Okay, and finally the input and the output directory. So I can go ahead and I can delete this portion as well. Now finally I have to give the input path and the output path, that is also can be given with the properties. Okay, and I have to again search for that property. Input directory, I believe input directory should be the one. Let us command F input dir. Yep, mapreduce dot input dot file input for dot input directory. That's the property. And we have input directories of input underscore data. This is on the HDFS. I hope you remember that. Similarly, output dir mapreduce.output dir, where should my results of my mapreduce job should be stored, which directory on HDFS. So that is, this is specified by this output directory, this property. Okay, that's it guys. So we are done here. We have given all the necessary properties, and now see, your driver code does not contains anything at all. It's just the initialization of your job object and waiting and then submitting a job. That's it. It's very simple now, and we have given each and everything through the conf file, and we don't have to now the conf file. And if you see, this driver code does not have anything, so it can be actually can be used anywhere, right? Only the mapper and reducer class functionality has to be changed, and then that will can be provided via your XML file. Now we have created this XML file here, myconf.xml. What I'm going to do now is to first in the foremost build this code. Since I have changed the code, so I'm going to build this code. I'm also um, delete that jar from my cluster, and I will first move my jar to the cluster, and also along with this I'm gonna move my, sorry, I'm not moving and I'm copying to my cluster. I'm copying the XML file also to my location, to my cluster. So that's the XML file. Now see this, how you will run this now. So you have the new jar and you have also the XML file here. So how do you want to, how will you run it? Use Hadoop jar. The same way, jar name, fully qualified driver class name. There is no input, there is no output since you have given everything in the XML file. You just need to say -conf myjob.xml. So conf option, you give -conf and my, okay, we forgot to give one thing here is the queue name, or else it will not run. Those who have not the capacity scheduler enabled, and so then that it's okay, it will by default go to the default queue. But since we have capacity scheduler everything installed, so that's why we have to provide the queue name, job.queue mapreduce.job.queue name. So this is a property. The value we are giving as a QA. I can manually change it right now in my on my cluster. Next time we will push it from our local machine. Okay, you have given this XML file. Now just need to say did we give the job name? If you have not given the job name, then you will see that it will give the jar name, right? The name of the jar. See, the jar name has came up. That means it has taken care of everything. And once it is done, you can, okay, it is already completed. I can go to my history server and check whether number of reducer tasks it is 0 or not. That verifies that everything worked as per our expectation. So this is how now your XML file, by the usage of this XML file, your driver code has shrunk to just merely 3 lines of code, and everything has given through the XML file now. So this is also an improvement. So you have first started with just simple main function where you have a lot of pains that you have to, if you want to do some kind of anything like number of reset tasks or change the input split size or anything, you have to change the code. And since you have changed the code, you have to rebuild the code, and then you have to move to the cluster, copy the jar to the cluster and then deploy it. Then I have introduced that using the tool runner, you have the flexibility to give the parameters or give the configurations on the command line at runtime. That gives you the more flexibility. But then you found out that how many parameters I can give, right? It can be a very cumbersome or a big command to provide the properties at the command line. Then we have introduced, okay, we can provide everything in the XML file, and that XML file can be given as an input to your MapReduce job. So all the properties can be specified in that XML file. Now you have seen that now everything is now very neat and clean here. Everything has been provided in the XML file. And that's all for today. In the next class, we'll see that how can we debug our MapReduce job. Right now, we have written our MapReduce job and we have seen the output. But nowhere I have told you that whether if the logic goes wrong, then how do you actually make sure that before you deploy into the cluster, your logic, your mapper and reducer logic is working as per your expectation. Yeah. And as a part of exercise, you can actually write um, your average, sorry, the various. So you can start with word count problem. You again you have to see the lecture number 13, lecture number 14, where we have the basics of our word count, overview of our map reduce, and we have solved. Also at the end of lecture 14, we have solved so many problems conceptually, and now we are ready to write those in Java. Inverted indexing was the one. Second, first word count, inverted indexing, average word length.
Can we have the Shakespeare file?
You don't have it. I'll send it.
No, I don't have.
Send it across. Average word length, term frequency problem, document frequency problem, right? And then you can always do and for all this problem statement, the input data could be a Shakespeare data. Input data could be a Shakespeare data for all this problem statement. Okay. Also, if you can write a MapReduce job to emit only words which are starting with, or use the Shakespeare data. Very simple problem. Shakespeare data and output only those words which are starting with vowels. You are not doing the word count or anything. You just need, I need a output files which has the word starting with the vowels, nothing else. For example, the output should look like this: add-on, abate, abet, abatement, abase, abeyance. So there are a lot of words like this which starts with vowels. I just need the output of my MapReduce job should look like this. Yeah. Thank you guys. Let's meet in the next class tomorrow. Bye. Good night.